Hello, and welcome to another edition of Math Teacher to Go. I'm Pat Doobie, and today we're going to be talking about truth tables. We're going to introduce the idea of truth tables using negation and or. This is section 3.2 of your text, and hopefully you will find this explanation clear and will help you to proceed through the material in that section. We're only going to talk about negation and or now. Later, in the next section, we will talk about if then and if and only if. So, when we're talking about truth tables, we're usually talking about compound statements. We're going to start out with a negation, which isn't truly a compound statement, but whenever you join statements together, you have a compound statement. Usually that's with an or, an if then, or an if and only if. We've already looked at the conditions necessary for a sentence to be a statement. First of all, it has to be a complete sentence, and then we must be able to assign a truth value to that complete sentence. Questions are not statements. Now, some things you may debate about the truth value, but you could assign a truth value. Each person could assign a truth value to the statement. So, we're going to use 4 example statements here because sometimes it's easier to understand when I take it from words and then go into symbols and letters. So we're going to use these 4 statements. New Year's Day is January 1st. Thanksgiving is in November. Boston is on the Pacific Ocean. And Florida shares a border with Canada. Now you're probably looking at those thinking, wait a minute. 2 of those are right and 2 of those are wrong. That's the point. I picked 2 true statements and 2 false statements to work with. And when we assign these truth values, we see that it is true that New Year's Day is in January. It is true that Thanksgiving is in November. Boston is not on the Pacific Ocean would be true, but Boston is on the Pacific Ocean is false. And Florida shares a border with Canada is false. Hopefully you knew all those things, but if you didn't, here they are. Boston is not on the Pacific Ocean. Okay. Sometimes I have little technical difficulties here. Just bear with me. So let's first start with negation. If I take the statement, New Year's Day is January 1st, that has a value of true. By definition, its negation must be false. If a statement starts out as true, its negation must be false. And this is a simple statement to negate because it doesn't have any of those quantifier words like some or all. When you don't have that involved, the negation is pretty straightforward. We just throw in the word not. So we said we assigned P to represent New Year's Day as January 1. So not P represents New Year's Day as not January 1, and its truth value is false. Just the opposite of what the truth value of the original statement was. Now when we look at the next one, statement R, we've labeled that R, Boston is on the Pacific Ocean, is false. When we negate that, we must get a true statement. We must get the opposite, and it must always be the opposite if the negation is going to work. So we negate it in symbols using what we call the tilde. On my keyboard, it's next to the 1 as a shift character. It's the very left of my computer keyboard. And Boston is not on the Pacific Ocean would then be a true statement, and it is necessary for these 2 to be opposite in order for R and not R to be negations of each other. So here you see when a statement is true, its negation is false. When a statement is false, its negation is true. This is the same for any statement regardless of the words it contains. It's not is contains. But so if I had just wrote R is true, what's the value of not R, and you had no idea what statement R was, you could still tell me it was false. So it's often convenient to summarize a bunch of facts in a table. So remember doing your multiplication tables? Well, we're going to do something similar. These are kind of like our arithmetic facts for this unit, for this whole unit, actually. So we call that table a truth table. And here it is written out kind of fancy. In the left-hand column, you have the value of the variable. And in the right-hand column, you have what the value of the negation of the variable is. So if you know that your statement was false, then you can look it up and say, oh, its negation will be true. It's kind of a lookup table. For the negation, it's so simple that that's probably confusing. So if that's confusing, you just don't worry about it. It'll make more sense when we do and or. So here's a less fancy version of the truth table. This is more like what you'll see. When you have statement P, you only have one statement. And that for one statement, there's only two choices of what it can be. It can be either true or false. When you look at two statements in combination, you have to look at all the possible combinations of true and false, and you'll get more rows. One statement, you only get 2 rows. So here's the first possibility. If statement P was true, then not P is false. The other possibility is statement P is false and not P is true. So if for some reason you couldn't remember that and you had this in front of you and you knew your statement was false, whatever the name of your statement is, it doesn't have to be P, whatever your statement is, if you knew it was false, you would look to the right and say, oh, its negation is true. So let's get into joining two statements together. A compound statement joins two simple statements with a connective. So the connectives are and, or, if then, and if and only if. We're going to work with just and or in this section so we can get the idea of how to use truth tables before we make them more complicated. The and or outcomes are pretty intuitive. You kind of can see, you can just using the words could see what the, how two truths could combine should result in a true. If then is a little less intuitive, and if and only if also is a little less intuitive. We use and or all the time in our language. So the idea is you take two statements that have a truth value and you combine them and make a compound statement. Now this becomes a statement itself, and it has a single truth value, but that truth value is obtained looking at the truth value of each of the simple statements and the type of connective used. Let's go into some examples of that using the 4 statements I laid out earlier. So let's use these two statements, P and Q. P will represent New Year's Day as January 1. Q will represent Thanksgiving as November. We're going to look at joining them with an and. An and is called a conjunction. The word con usually means with, together, and just remember conjunction and. Disjunction is or. They're in alphabetical order. A comes before O, C comes before D. And the symbol for and is here. Now the symbol for or is that. To keep them straight, here is what I remember. If I draw a line across each of them, which one looks like an A? This one looks like an A, it goes with the and. Okay, so New Year's Day is January 1, Thanksgiving is in November. If I join them with a conjunction, the words would say New Year's Day is January 1, and there's my connective, Thanksgiving is in November. So this statement was true, and this statement was true, so I'm joining two true statements together with an and. In symbols, statement P was the first one, statement Q, and there's my connective and. That's how you write that in symbols. That's mostly what we're going to be working with. So if I say New Year's Day is January 1 and Thanksgiving is in November, you would say I've just made a true statement. And in your mind, you're thinking, yeah, both of those things are true, so that's true. And is only true when both sides of the connective are true. And you're only ever looking at two statements combined with a single connective at a time. Even though the problems start to look really long, we'll see a kind of long one at the end here, you're only looking at these in pairs around a single connective. So in symbols, what I just said would have been written this way. P, the upside down V is an and, Q equals T. And the reason it equals T is P was true, Q was true, Q is true, so when I join them but together with an and, the result is true. Let's look at some other possible combinations using the and. Okay, so now I'm going to look at statement P joined with statement R. New Year's Day is January 1. Boston is on the Pacific Ocean. I'm going to join them with a conjunction. So the way that reads is New Year's Day is January 1, and there's my connective, Boston is on the Pacific Ocean. Now, remember, and could be but, however, there are other words that represent and also. But when you see the word but, when you see the word however, it means and. So this one was true, but this one was false. Boston is on the Pacific Ocean is a false statement. In symbols, I would write P and R just like I did with P and Q. And then, but if I said to you, think about this, New Year's Day is January 1 and Boston is on the Pacific Ocean, you would call me a liar, okay? The only time when any of these statements are false is if you can point out evidence that I have lied. In this case, the evidence that I have lied is I said and Boston is on the Pacific Ocean. This is false. The and implies that everything I'm telling you is true, not just some of what I'm telling you is true. So you are going to say that joined together, this is a false statement. You're going to say, no, Professor, you're lying. Boston is not in the Pacific Ocean. And then, or hopefully you would say that at least, when and is used, the compound statement is only true if both statements on either side are true. It's the only case you get a result of true when you join two statements together with an and, is if they both started out true. So in symbols, we would say P and R is false. And that's because anytime I have a true and a false, I get a false. In order to be true, both sides of the and must be true. That's the only way you get a true out of a conjunction or an and statement. So what if I reverse it? If I said Boston is on the Pacific Ocean and New Year's Day is January 1st. Same two statements, I've just switched the order. Well, you would still call me a liar. You would still say this is false. And that's because it doesn't matter. The order doesn't matter in an and the order doesn't matter in an or. In an if-then, it does matter, so don't assume it never matters, but in the and the or, it does not matter. So in symbols, I have R. This time the R goes first, because I use statement R first, and then I use statement P. And there's the and. There's the and. P is false, because I had a false and with a true, and I get a false. So far we've looked at a true with a true with a false, and a false with a true. With two statements, there are four possible combinations. So we need to, in order to make a truth table, we need to have basically, what are our arithmetic facts for all four possible input combinations. And you can probably guess the remaining one is false with a false. Now, every time I set up a truth table for two statements, I am going to get 4 rows. So I get 1, 2, 3, 4 rows. And I'm always going to have the letters going in alphabetical order, left to right. And I'm going to start with 2 trues, then 2 falses, then I'm going to alternate. And that will ensure that I get every possible combination and I don't repeat any. That will be something we will work on in class too. So what if I have a false and a false? If I say Boston is on the Pacific Ocean and Florida shares a border with Canada, well, I'm a liar on 2 counts here. So you would say that's a false statement. No, that's not right. So and is only true when both statements are true. So and is only true if both simple statements are true. You only need 1 false to ruin it. In this case, I have 2 falses, so clearly my outcome of R and S is false, because a false and a false is a false. Okay, so here is the summary of what we just did. Over here to the left, you see I've got the 4 possible combinations: a true and a true and a false and a true, or a false and a false. And and I have a mistake here. This should be a false. I will fix that in the typed notes. But a false and a false is a false. I have it correct in the truth table over here, but a false and a false should be a false. So this is what we call a truth table for a conjunction. And what you do is you look up the combination you have. If you have a true on the left and a false on the right, you look up the row that has true, false, because you have true, then false, and then you see the outcome is false. So you can replace the true and false with simply a false. That is how you would use a truth table. Now you're going to have to memorize these truth tables. By memorize, I don't care if you jot them down quickly and then use them, but you have to be able to write them out and jot them down. You need to know that in order to get a true out of a conjunction, both sides have to be true and every other case is false, and things like that. Okay, so what about the other type of connective we're looking at today? Disjunctions. So a disjunction is an or statement, and it is represented by an upside down V. I'm sorry, a right side up V. It's not the and, because if I draw a line through this, it doesn't look like an A, so it can't be the and, it must be the or. Okay, if a person says New Year's Day is January 1st or Thanksgiving is in November, we're going to say that's true. You might be tempted to say it's false because both things are true and you expect the or to be one or the other. In this course, we use what we call the inclusive form of or, where two true statements joined with an or are true. I didn't lie to you. You can't say I lied to you because both of those things are true. Now, only one of them would have to be true if I use an or in order for me to be making a true compound statement. So that's the big thing to remember when you're memorizing these. In a true and an or, you only need one true to be true, but in an and, you need both true to be true. So in symbols, what I've just said would be here. P or Q equals true. And that's because the arithmetic fact for or is true or a true will result in a true. Again, with disjunction, let's look at two different statements. Well, one different statement. New Year's Day is January 1st, or Boston is on the Pacific Ocean. I gave you a choice, one or the, if one of them is true, then my statement is true. Now, you can say Boston's not on the Pacific Ocean, but you haven't lied because New Year's Day is January 1st. So in an or statement, we only need, so this one is true, there's my or, but this one is false. But the fact that I have a true on one side of the or means the whole thing is going to be, the compound statement will be true. In symbols, here's how we write it, and here's our arithmetic fact. True or false is true. Now, the next thing I do is if I switch the order, it doesn't matter. I've still said one true statement, so the or would still be true. And that's in the next slide, I believe. Yeah, so if I switch the order, doesn't matter. The bottom line is when I have a false or a true, I also get a true. And then, so now I've taken care of true, 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 false, false, true, and the last case will be false, false. That'll be on the next slide. So now if I give you two simple statements that are false joined with an or, it could sound like this. Boston is on the Pacific Ocean, or Florida shares a border with Canada. And you scratch your head and you say, I thought my professor was smart. No, it's a false statement. You say I'm lying because in both cases I'm wrong. It's not true. Neither one of those is true. So if you can say I'm lying, it's false. In symbols, R or S equals false is what we will say, because Boston, we've said is statement R, Boston on the Pacific Ocean, and Florida was our statement S from the beginning of this video. And what the bottom line, where you really need to get to, is that when you join two falses together with an or, the result is false. So now we've looked at all four cases for our or truth table, and let's see what we get. So what I get is, over here on the left, I can see that the only time an or is false is if they're both false. With an and, the only time it was true is if they were both true. So you need both things to be true for an and to get a true. You only need one of the statements to be true to get a true for an or. And here is the truth table. If I was trying to figure out the value of something false ored with something true, I would look up that row. This is the value on the left, right? Doesn't matter what the names are. I'm dealing with statements R and S or T and V. It doesn't matter. This is the state. Basically, this whatever's in this column is what's on the left. Whatever's in this column is what's on the right side of the connective, and the connective is the or. So on the left, I have a false. On the right, I have a true. And here is my result. My result will be true. So I will use these facts to simplify long compound statements that are joined with more than just one connective. And we'll see an example in a moment here. So you need to know these. Now, I've done something here which I hope is not confusing, but the inputs for two statements always look like this. And if you're labeling the columns, do them in alphabetical order, left to right, P comes before Q. And then you will always have 4 rows for 2 statements. 2 statements will always be 4 rows. When we get to 3 statements, you'll see we have 8 rows, but that comes a little later. So to set up these 4 rows, you must always do it this way. Left to right alphabetically for the letters, and then going down, it's a true and a true, and then a false and a false. Because now you cover the case where P is true, and then Q could either be true or false. Cover the case where P is false, and then Q could be either true or false. You must do it in this order because it's hard to compare things if you have random order. And later we'll be doing a lot of comparing the outcomes of statements to see if they're equivalent. So you can't set them up randomly. You must set them all up the same. Now, what I've done here that maybe is a little different is I've put your outputs for each. This is for the AND. Here's what you get for each of those 4 rows, and for the OR, here's what you get. So you can memorize this as one table. You can memorize it as individual tables. You can memorize the ideas and be able to create the tables. You need to know these math facts, and you need to know them like immediately, because we'll be using them, and you'll be going, where did she get that from? Stop me if you don't know, and I'll be glad to explain it again, but you will need to memorize it, and this quite well could be a quiz topic very soon. So let's go on and see how we use these. So we use these to decipher more complicated outcomes from more complicated topics. We have lengthier compound statements. Here's an example. I'm going to give you the values of P, Q, and R. And later on, we learn to write out truth tables for all the possible values, but that will come later. I get three statements here. We're not ready for that yet. But what you're going to see is you're only ever dealing with 2 statements at a time if you're given the values of your statements. So I want you to find a truth value for P and not Q, combined with an OR with not R and Q. And the parentheses are important. You're going to work inside the parentheses first, just like in algebra class. So here's how you start. You replace P with its truth value. You replace Q with its truth value, so there's P. There's Q is false. Notice I just left the not there for now. I'm just replacing. And R becomes a T, so R became a T there. And Q, I was told, was false, so Q became a false there. Now you're going to replace, so you do that. Now this is the statement you're dealing with. Now you have to know how to combine. We're still working inside of parentheses first here. So what I do is I replace the not F with a T and the not T with an F. That's the next step. Now I have a true and a true, or a false and a false, and I have to do the parentheses first. So here's what I started with, true and true, or false and false. And I'm going to look for the true and true. I'm going to simplify that first. I look in the AND table, and I see, and if you have the notes printed out, you can look, or I just know that a true and a true, oh yeah, that's how I get a true from a compound AND statement. So this set of parentheses becomes this true here, and I've got way too much marking going on. This set of parentheses becomes this red true here. Now I have to deal with the next set of parentheses. False and a false. Oh, I've got 2 falses with an and. That is definitely false. So that becomes that. So now my new problem looks a lot simpler. I'm just doing a true or a false, and the result of that is true. So do these a step at a time, and that will be, when you first start doing these, you may have those truth tables in front of you. It might be a good idea so you know you're doing them right and you're not struggling because you haven't memorized them. And in the process of using them, you will start to memorize them also. So that would be a task in Section 3.2 homework, would be to know how to use these truth tables. All right, that's all for this edition of Math Teacher to Go. Hope to see you soon.